This is task 2, question 2 from page 7 of the Digital Electronics course notes. In this problem, we have three inputs to our system, A, B, and C. And so I've already put up the standard first three columns of a 3-input truth table, and you'll find this on page 6 of the course notes. We are asked to find the value of D, E, and Z. D and E are intermediate values, and Z is the final output value of the system. And so what I'll do is I'll add columns for these three locations in our circuit that have been labelled in the diagram already. We solve this problem in a manner similar to what we've seen in class before. So we take each gate in turn and work out what the output of the gate is, because we can see here, for example, that D is the output of the first most left-hand gate, and that itself in turn serves as one of the inputs for the second gate. So we can't work out what E is before we know what D is. We can't work out what Z is before we know what E is. So we have to work left to right in this diagram. So I'm going to draw a box around the first AND gate here. And I'm going to indicate in the column the inputs. The inputs to this AND gate are A and B. So they're going to tell us what to put in column D. Now, when we're looking at logic rules for individual gates, what happens is that we'll only get a 1 out of an AND gate if all the inputs are 1. So if we start at the top row of our table, which is the row 0, 0, 0, and work our way down, we're only going to put a 1 in the D column if A and B are both 1. So we can actually see that in every row as we go down, they're both 0 in the first two rows. Only B is 1 in the next two rows. Only A is 1 in the two rows after that. It's only the final two rows of our table are A and B both 1. So that will be the only two rows in which D is 1. So D is only 1 if A and B are both 1, because it's output of an AND gate with A and B as inputs. So let's now consider the next gate in our diagram. The next gate is the gate here. I'm drawing in the blue box, and it has inputs C and D, which I'm indicating with arrows here, and its output is E. And this is also an AND gate, so the same rules are going to apply here. We're only going to get a value 1 in column E if the value for C and the value for D are both 1. And looking at our table, there's actually only one row in which C and D are both 1 at the same time, and that's the final row of the table. So we can put in zeros for every other row of the table. And finally, we deal with the right-handmost gate. This is a NOT gate. A NOT gate takes whatever value is put in and gives us the opposite value out. So if a 0 goes in, a 1 comes out. If a 1 goes in, a 0 comes out. So our input here, I'm marking with the green arrow pointing down, is column E. And what this effectively said is whatever is in column E, the opposite will be in column Z. So E is 7 zeros and a 1. Z will be 7 ones and then a 0, because in each case, it's the opposite of what's in the column before it here, because E is our input to the NOT gate with output Z. And that concludes task 2, question 2.